Solve Cambridge IGCSE Physics Paper 4 Theory, and the variant is 0625 slash 43. It's a May June 2023 paper. So, right, let's start off with question number 1. Figure 1.1 shows a balloon filled with helium gas. The mass of the balloon is 120 kilograms. Calculate the weight of the balloon. Show your working. So, simply, you have to do the same. Basically, you have to multiply this 120 with 9.8 to get your required answer, which is going to be 1176. So you can round it off to two significant figures, so it's going to be 1200 newtons. The resulting force on the balloon is 54. Show that the acceleration of the balloon is 0.45. So we know that the force is 54, and we can apply the formula F equals to ma. So force divided by mass is equals to acceleration. So force is 54, and the mass is 120. So if you divide this, you will get the required answer for this. The balloon accelerates upward from rest at 0.45 meter per second square for 8. So we need to find out the velocity of the balloon after 8 seconds. So we know that the formula for the acceleration is the velocity divided by time. So we need to find out the velocity. So acceleration times times is equals to velocity 0.45 times 8. So it's going to be your velocity. Velocity is going to be 3.6 meter per second. So this is already into significant figures. No need to change that. Okay, calculate the distance traveled by the balloon in first 8 seconds. So again, speed equals to distance divided by time. So we need to find out the distance. Velocity times time is distance. So velocity is given 3.6 and 8 is going to be distance. So this is going to be okay. Just a second. We need to find out the average distance for this. So we have to do the other way around. So it's going to be average speed times total time taken equals to total distance. So we have to apply this formula. This is the average speed equals to total distance divided by total time. So again, 3.6 divided by 2 because it's average time, and then you have to multiply it with 8. So it's going to be 14.4 meters, which is going to be 14 meters. So this is going to be your answer. By the way, if you want to do this same, so 3.6 plus 0 divided by 2, this is the average speed formula, and this is how we are going to solve this question. Okay, define pressure. Simply write the formula for this. Pressure equals to force over area. Describe how pressure in liquid varies with its depth with its density. So obviously with the depth its pressure will increase, because we know that the pressure is directly proportional to the depth, and with the density obviously it's going to increase over there as well, because the formula is going to tell us that rho gh. So it depends upon the density and the height. State 2 energy resources for which the sun is not the main source. So it's going to be nuclear energy. It's going to be, can be a tidal energy, or you can write it geothermal, because they are not dependent upon the sun. State and explain whether each of the following methods of electrical power generation is renewable. Power generation in a nuclear power station is a non-renewable source, and then is basically nuclear element, radioactive element, nuclear fuel is used up, so it's not the renewable energy source. So power generations from waves in the sea. So yes, this is a renewable source, renewable energy source. Nothing is used up, nothing is used up, and wind is always there. So any of the reason you can write it down over there. Okay. Okay, state which of the state of matter, solid, liquid, or gas has the greatest thermal expansion and which has the least. So obviously the greatest expansion will be gas as compared to solids. Described in terms of motion and arrangement of the particle, the structure of solids in and gases. So in solid, the particles, they are going to vibrate. The particles are going to vibrate. They are tightly packed, fixed volume. And for gases, they have random motion, and they have no fixed shape. They are not tightly packed as compared to solids, so they move freely. Define specific heat capacity. Q equals to mc delta theta, or you can write it E is equals to mc delta theta. So we are looking for specific heat capacity, so make C subject, E is equal to m delta theta. So this is going to be your um, uh, formula for the specific heat capacity, or you can write it down: amount of heat required to raise the temperature of 1 kg of substance by 1 Kelvin. It's up to you how you are going to write it down. Okay, I'll write down the definition: amount of heat required to raise the temperature by 1 Kelvin, temperature of 1 kg of substance by 1 Kelvin. Okay. A student carries out an experiment to determine the specific heat capacity of a metal. A cylinder of a metal is heated at 12 volts. The critical heat state the reading that students take. So you can see from the formula, which is Q is equal to mc delta theta. So he wants the reading, like he wants to know the time, he wants to know the mass, he wants to know the initial temperature, which is going to be initial, and TF, which is going to be temperature final. So you can see the quantities that you or the student might need. He might be requiring mass, he might be requiring the temperature, change in temperature, which you get it from here, delta T, or you can write delta theta over here. It's up to you. Okay, so sometimes the Q is also being replaced by E as well. Okay, moving to the next question. Figure 4.1 is incomplete ray diagram showing an object O converging lens and the principal axis. The principal focus is to complete the ray diagram to show the. Okay, we know that if an object is placed inside the focal length, so the object is going to be uh, it's going to be like this. Okay, so the point where it is intersecting, that image will be drawn like this. So you have to use the rule, image creation rules, to make the image behind the object, and you have to complete the ray diagram drawing and limit the image. Yes, you have to label the image by I. So this is how you do get this. Circle 3 description in which describe the image formation in one. So it's going to be enlarged. Yes, the image is enlarged. You can see this thing is upright. Yes, and it's virtual. You cannot get it on the screen. Okay. So virtual images are those images which you cannot captured on the screen. State the name of the defect of the vision that can be corrected by converging lens. Okay, so for converging lens, you can use this. I mean, the defect that is caused, that is corrected by, or that is fixed by converging lens, is sightedness, or farsightedness. Sightedness. Describe how converging lens corrects the defects in eye. You may find it helpful to sketch a diagram. Okay, if this is your human eye, and this is going to, the image is going to be found behind the retina. So this is your retina. So in order then the person cannot see the things correctly. So basically what you do is you put a converging lens, so then if the images are going to be made on the retina, and then the object can be seen correctly. Okay, so converging lens decreases the focal length. This is what is going to happen, and then its rays converges on retina. So when these rays converges on retina, so you can easily see the. Two types of electromagnetic radiations are used in glass optic fibers for high-speed broadband. State the type of electromagnetic radiation other than visible light which is used in glass optical fibers. So it's going to be the infrared. Okay, give two reasons why these two types of electromagnetic radiations are used in glass optical fibers for high broadband speed. Because glass is transparent. Glass is transparent to visible light and can carry light at a faster rate. Can carry uh, I have to fix this. Just a second. Can carry high rate of data. Okay, the critical angle of the glass in an optical fiber is 45. Calculate the refractive index. Sin C equals to 1 over n. So we need to find out the refractive index. So 1 over sin C is equals to n. So put the values. N equals to sine 45. So it's going to be 1.4. So refractive index is a ratio, so you don't need to have any angle for that. Figure 5.1 shows an optical fiber made from glass fiber in this. Draw carefully a ray of light in the fiber undergoing total internal reflection. So you can draw this like this. Make sure you do the normal thingy, and then you have to draw it like this, and it goes on. So this is again your normal, and this is your angle of incident, this is angle of refraction. So angle of incident is equals to angle of refraction. So this is what you need to do. Okay, moving to the next question. An electric heater uses the resistance wire of resistance 26 ohms, and the power dissipated in the resistance is 2500 watts. Okay, calculate the current in the resistance of the wire. So when we know the formula is P is equals to I square R, and we need to find out I square. So basically we need to find out the current. So I'll make it subject. So it's going to be 2500 divided by 26, which is going to be 9.8 amps. So this is your final answer. Okay, now moving to the next question. The resistance wire of a heater has a length of 1.2 meters, and the cross sectional area of this is this. Okay, the length is 1.2, the area is this. The new heater designed same material, and this has a length this, and the cross section. Calculate the resistance. Okay, so we have to use simple ratio method, which is going to be L2 over A2 divided by L1 over A1. So if you do this thing, so it's going to be A1 over A2 times L2 over L1. Both have the same thing, material, so it's going to be R2 over 26 equals to 7.9 divided by 5.8 times 1.8 divided by 1.2. These are the values given in your question, so it's going to be 53 ohms is your right answer. The 2500 watt heater is used to in a country where electricity costs $0.3 per kilowatt. Calculate the cost of using heater continuously for 2 days. Okay, we know that energy is equals to power times times. So power is going to be 2500 watts, so you have to convert it into kilowatts or divided by 1000. Now for 2 days it's going to be 2 times 24 hours times 0.3, so it's going to be $36. So this is the rate which we have uh, calculated from the question. Okay, the voltage across the primary coil of a 100% efficient transformer is 220 volts, and the voltage across the secondary coil is 12 volts. The current in the secondary coil is 2.5, and we calculate the current in the primary coil. So okay, we will use Vp, or excuse me, just a second, I'm sorry. We are going to use Vpip equals to Vs. So Vp is 220 times Ip Vs voltage in secondary is 12 times 2.5, and then it's going to be Ip is equals to 12 times 2.5 divided by 220. It's going to be 0.14 amperes. So this is going to be your final answer, because I have done the two significant calculations as well. Okay, let me check if I have done something wrong. Okay, no issues. This is fine. I thought I missed some questions. Okay. Now moving to the next question. Calculate the ratio of number of turns in the primary coil to the number of turns in the secondary coil. So it's going to be Np over Ns equals to Vp over Vs. So Np over Ns is going to be 220 divided by 12. So if you do the ratio thing, and then it's going to be 18s and 12 ones are, and 12 18 are, so it's going to be 18 ratio 1. Okay, moving to the next question. During beta decay, one of the neutron in nucleus change state, what happens to the neutron? So we again, simply you have to remember this thing. Neutron change, there will be change in proton, and there will be change in proton and electron. Okay, explain how charge is conserved during this change, because the proton is going to be increased by +1, electron is going to be -1, so total charge again is going to be 0, because if you add +1 -1 is going to be 0. Okay, complete the nuclear equation for the alpha decay. So we know that alpha is 4 and 2, and radon is 2 turned to isotope of polonium. So polonium is P naught. So 212 minus 4 is going to be 208, and 86 minus 2 is 84. So this is how you get your answer. Okay, and yes, this is going to be your right answer. Okay. Okay, I'm going to add one more thing over here, how the charge is going to conserved. You can see this thing. This is going to be, if there is an element which has this atomic mass and atomic number. So if it is there is a beta decay, so -1. So if you get another daughter product y, so it's going to be 2. It's going to be 2, and it's going to be +1. So this is going to be +1. Just forget it. I'll share you this thing in my next video. At the moment, you just write this thing. Proton is +1, electron is -1, total charge is going to be this. Okay, moving to the next question, and this question shows that, okay, figure 9.1 shows the sun as the center dot, and the planets Saturn, Jupiter, and Earth labeled S naught, J naught, and E naught. The planet orbits the sun anti-clockwise from the Earth's orbit. The planet appears aligned. Okay, this is how it is. So this is your Earth. Just a second. This is your Earth. This is your Jupiter, and this is your sun. Sorry, Saturn. Sun is here. This is your sun. Okay. In the middle, it is the sun, Earth, Jupiter, and Saturn. Assume the Saturn takes 30 years to orbit the sun, that Jupiter takes 12 years to orbit the sun. Okay. We are assuming that Saturn takes 30 years to orbit the sun, and Jupiter takes 12 years to orbit. On the figure 9.1, mark the position of Saturn and Jupiter 5 years after the original position shown. So this is this thing. So how you are going to solve this is basically your math skills. The total angle of this circle is 360. So 360 is covered by in 30 years. Okay, the Saturn takes 30 years to cover this. So what angle will be there for 5 years? So if you do the simple calculation, so it's going to be 360 divided multiplied times 5 divided by 30 is going to be 60 degrees. So with the help of a protractor, you are going to make an angle of the for the Saturn is going to be like this. Angle is going to be 60 degree. You have to use a protector, okay? Without the protector you won't be able to do that. Okay, label these point S1 and J1. Okay, this is going to be S1. I have placed S5. I thought after 5 years it's going to be this. This is S1. Okay, now for the Jupiter, we need to find out what is going to be the angle. So again, we will do this the same thing. Okay, Jupiter is again 12 years. So let me do this thing. 360. Okay, 360 degrees for 12 years. Okay, and so for after 5 years it's going to be after 5 years it's going to be x. So again do the calculation. So x is going to be 360 times 5 divided by 12. So what it would be, just a second, let me do. So this is 150 degrees. So now you have to make angle at again start off with this, and that's going to be 150. So the Jupiter is going to be 150. So Jupiter will be over here and we will call it as J1. Okay, this is done, this is done, we have labeled this thing. Okay, now moving to the next question. On the figure 9.1, mark the position of Saturn and Jupiter after 20 years of original position in the figure shown in this, and label them as S1 and S2. Okay, again you have to do the same things for, let's say, Saturn planet there. So 30 years is equals to 360. So 20 years will be x. So x is going to be 240 degrees. For Jupiter, Jupiter is going to be again 12 years is going to be 360, and 20 years is going to be x. So it's going to be uh, 600 degrees. Okay, now how you are going to do this thing for Saturn? If this is the circle, if this is the position, so it's going to be like this position. It's going to be this angle which is we are looking for. So this is going to be your S2, which is going to be 240, and for 600, because it means that it has completed one rotation and now in the second rotation is going to be at this is 360 degrees, 360, and this is going to be 240 degrees. So it's going to be like this. Okay, the same thing. So this is going to be your J1, J, sorry, 2. These are the positions that you have to make in your previous diagram. Okay, and label these things as it is. State what is observed from the Earth's orbits after 20 years. So they will be aligned after one another, because you see that they both have the same angles, aligned one after another, just like a eclipse. Okay, choose two words from the list to describe each planet. Jupiter is large and gaseous planet, whereas Earth is small and rocky planet. So you can write it down over here. The average density of Jupiter is much less than the Earth. The gravitational field strength at the surface of Jupiter is greater than that of the Earth. Explain how these differences in density and the gravitational field strength are consistent with your answer to C1. So density, Jupiter, okay. Jupiter. I hope I have written the correct spelling for Jupiter. Okay, it's TER. Okay, Jupiter's density is less because it is made up of gases, and whereas Earth's density is greater because it's a solid. Whereas gravity, if you talk about gravitational field, Jupiter's has gravitational field strength more because it has more mass, is more because more mass, or it is larger. Whereas if you talk about Earth has less gravitational field strength because its mass is less as compared to Jupiter. Okay, moving to the next question. The average density of the Jupiter is this and its volume is this. Calculate the mass of the Jupiter. So we know that density equals to mass over volume. So density times volume is equals to mass. Density is 1300 times 1.4 into 10 to the power 15. So if you multiply this thing with this, so you will end up with a 1.82 into 10 to the power 27 kg. So this is your required answer. But before that, you must remember this thing. You need to convert this into meter cube. I forgot to tell you because I have already done this in another paper. So you need to convert, first step one, you need to convert this into meter cubes, and this is going to be just a second, 1.4 into 10 to the power 24 meter cube. And then you have to place this value. Let me fix it for you guys. 24 over here, and then you will get the right answer, which is going to be this one over here. So I think we are done with this paper. Let me oh, we have one more question. Show that 1 light year is equals to 9.5 into 10 to the power 15 meters. So this is the thing. Basically you have to remember when converting the distance into light years. So we know that the speed of light is 3 into 10 to the power 8 meter per second. So we know that the number of seconds in 1 year are number of seconds in 1 year is going to be 365 days times 24 times 60 times 60 is going to be 315360000 seconds. So we know that distance is equals to speed times time. So if you multiply these two figures, 3 into 10 to the power 8 times 31536 123, so you will end up with 9.5 into 10 to the power 15 meters, which is your required answer. State one measurement that is taken when determining the speed v at which a galaxy is moving away from the Earth. So it's going to be a redshift in which the wavelength increases, there will be a change in wavelength. Write down the equation relating to v and distance for a far galaxy. So it's a Hubble constant equation, and that is going to be h naught equals to v over d. State how the distance of d of far galaxy can be determined other than using the equation 2. So we can do that with the help of brightness of the supernova or a star. Supernova, or you can do it with the brightness of the star. So thank you very much. We are done with this paper.